So the purpose of this activity is just like what we did with the carts in the hallway, except that was a position versus time graph activity. This one's a velocity versus time graph activity. So we have kind of a lab activity on both of the important types of graphs. Okay, so the problem we're investigating here is the change in velocity of a vehicle measured over time tells us acceleration. In other words, it's talking about this formula. Okay, how can graphing help us calculate acceleration? In other words, if I had a velocity versus time graph, okay, if I had a velocity versus time graph and it had a line on it like this, how would I get the acceleration from that line? Okay, and we talked about this the other day, how this formula is very similar to this formula. Final position minus initial position over time. Okay, we talked about how this one was really just a manipulation of that, y equals mx plus b. Okay, would this be similar as a situation? Right? Does it set up kind of the same way? I would have y, I would have b, and then this is the x-axis, so y minus b over x would be the same thing. Okay, this would be y minus b over x. Okay, that idea. Okay, so our variables here. So we're not actually running the experiment, so I'm going to help you out here because it's sometimes tough when you're not actually running the experiment. Right? Same as last time. Our manipulated variable is going to be time. Time is going on the x-axis. The manipulated variable always goes on the x-axis. So our manipulated variable is time. Okay. Now, your reasoning should not be because the manipulated variable always goes on the x-axis. Okay. You should talk about how, for the situation we're in here, which is that cars are being raced down a track. Okay. The longer they'd be allowed to race, if I let them go longer, they will go, well, not only farther, but we're not really concerned with the farther part. We're concerned with the faster part, right? Okay. Which means then that since this is a velocity versus time graph, the part I'm watching change would probably be the, which variable? The responding variable, right? If the longer I let them go, the faster they go, then it's the faster part that's responding. Okay. 3 controlled variables. Let me outline this experiment for you so that you can think up 3 controlled variables for this experiment. What's going on is all of the cars in this list down below were brought to the same location on the same day. And they were each accelerated down the same track by the same driver with their times being measured and their speeds being measured. Okay, so they were all brought to the same facility where they were raced on the same day, on the same track, by the same driver, okay? And then they had their speeds and times recorded. Well, that's why it's the same driver. Okay, for our hypothesis, we're going to ignore what this if part here says, okay? Our if part should talk about what acceleration is. Okay, so the if part should say, if acceleration is, and can you give me a definition of acceleration? And you have a definition of acceleration in your notes, by the way. Okay, the and part's going to describe the experiment. Basically, we're making velocity versus time graphs of the racing data for several cars. The then part, just like the last lab, I want to know how can the velocity versus time graph be used, I'm running out of room here, to calculate acceleration. Okay, questions so far? For the and part, just basically describe what's going on here. We're making velocity versus time graphs for racing data for several cars, right? Okay, so the procedure is basically going to be that you're going to plot graphs for 5 cars from this list. So you choose whichever 5 cars you want from the data list here. Okay, and what you are going to graph is their velocities versus time. Now I'm going to run through, I'm going to make 2 of them here, okay, just so that you guys can kind of see how this is going to look. We're actually going to be able to do this fairly quickly because the speeds are going to be the same numbers for every car. So we'll just be able to copy one of the columns over for every car. All we have to do is fill in the different times that each car would have. Okay, so it'll actually go pretty quick. Okay, so what I need everybody to do is kind of follow along with me here, okay, so that you can see how the graphs are going to be built. Like I say, I'm only going to build a couple. Okay, I'm just going to get the data called up on my other screen here. Okay, so I want you in your lab here. So if we're back on this screen here, okay, if everyone can get back to the task screen, you're going to create a Google Sheet. All right, so we're just going to click on create, and we're going to create a sheet. Okay. And if you give it a second, okay, it'll come up with the same name. Okay, so that'll be what we'll use. We'll just open that up. Okay, which one do I want to have on the x-axis, time or velocity? Time. It's a velocity versus time graph. Time has to go on the x-axis. So my first column will be time. So I'm just going to write time up here. Okay, and the units for that are seconds. Okay, and I'm just going to pick the Ferrari because it's the first one. Okay, so its times are 0 and 1.6, 2.1, 2.6, 3.7, 4.5, 5.7, and 7.9. All right, and then I'm going to go over here and I'm going to put in the velocity data. And that is in meters per second. Okay, so the first one is 0. Okay, and then we have 13, 18, 22, 27, 31, 35, and 45. Okay, and I'm just going to write here time, and I'm going to put up in this with velocity here. I'm just going to add in that this is going to be Ferrari. Whoop. Ferrari. Okay. Just so I know which car it is when I'm looking back on this. Okay, so now I want to graph this. All right, so same as we did before, I'm going to highlight, click and drag and highlight all my data. Click Insert and Chart. Okay, they have abolished the old chart editor, so we do have to use the new one. Okay, and that's fine. We'll make it work. So we don't want a column chart. We want a scatter plot. So you got to scroll down until you see scatter. Click on that. Okay, and there you've got your points for your Ferrari. Now, obviously, we need to make this graph look a little bit better, right? So we're going to go over to Customize now. And this is where we can put in our titles and things like that. We don't need to do anything with chart style because it's fine. Okay, but we're going to change the chart title to Ferrari. Oh. And I'm just going to write velocity versus time with capital letters. And I can't spell today. Okay, so now I've got the chart, the title in there. Now I want to click up here beside chart title and put in the axes titles as well. Okay, so my horizontal axis is going to be time in seconds. Okay, and I got to do the same thing for the vertical, except it's going to be velocity in meters per second. Whoop. What the heck is going on here? Oh, I'm hitting caps lock, that's why. Meters per second. Okay, so I've got the title done and the axes labeled. Now I want to click on series. This is where I can put in the trend line and the equation. Right, so I'm going to click on series. I can make those points smaller if I want to, but I don't really need to. I just want to click down here where it says trend line. Just check that box. Right, it'll put the trend line in there. I do want a linear trend line, so I'm going to keep it like that. Okay, if I scroll down a little bit further, you'll see that there's an option for label, and I want to click on that and say use equation. All right, so it is showing me here that y equals 5.46 times x plus 4.71. Right, so it spit out the y equals mx plus b for the Ferrari. Okay, so I've got one of my graphs. I'm just going to close that up now. That graph is good. I need to make 5 of these. Okay, remember there are 5 cars. I'm graphing 5 different cars. So what I'm going to do is just click and drag this a little ways out of the way. Okay, and I'm going to click down here. See, there's a plus indicator down near the bottom here. That's going to add another sheet. And on that sheet, I'm going to graph the next car. So I'm going to click add sheet. Right, and I'm going to put in the times for, I'm just going to do the Corvette because it's next in line. So time in seconds. Okay, and we got 0 and 1.5 and 1.9 and 2.9 and 3.8, 4.4, 5.9, and 7.8. All right, and I'm just going to write up here that this will be velocity for the Corvette. And that's going to be in meters per second. Okay, now here's where I can save myself some time. Rather than typing in the numbers for this, I'm going to go back to sheet 1, and I'm going to copy these numbers here because they're the same for every car. Right? Only the times are different for every car. The speeds they measured them at are the same. Okay, so I'm just going to go Control C to copy those, go back to sheet 2, and press Control V and paste them in there. Now I can make my next graph same way I did the last time. All right, questions on how we're building the graphs? Okay, I'm going to go back to explaining the rest of the lab report here because you guys can build those graphs in a minute. Okay, so what you're going to need to do in the analysis, okay, is fill in this chart. All right, so for the Ferrari, okay, so I'd write Ferrari in here. I'd put the slope, which I get from the equation Google Sheets spit out for me. Okay, I'd put in B with the proper units, whatever the units for B are going to be. Google Sheets will not spit that out. You'll have to figure that part out. Okay, and then rank them. Which was the fastest accelerator? Right, rank them from 1 to 5. Fastest being 1, slowest being 5. Okay, and then for the last part, calculating the displacement. So you can see here that that's analysis question number 1. Analysis question number 2, from your data, the slopes, okay, which of the cars accelerated the fastest? So that's ranking them. So that's essentially filling in this part, right? And then for number 3, using your best fit line, and that's the key here, calculate the displacement of each car in reaching 45 meters per second. Okay. Now, how do we calculate displacement from a velocity versus time graph? Right, we're looking for the areas underneath the line, but there's a little bit of a trick here. Okay, and I'm going to just show you that with this here in a sec. Okay, so I'm just going to copy this over here for a second, just so you can see what I'm talking about. Okay, so I've got this here as my graph. I need to calculate the area under the line, okay, for the car to reach 45 meters per second. This is my point for 45 meters per second. Is it on my line? No. I want to use my line here, right? So what I need to know is, right, how long did it take according to my line for the car to reach 45 meters per second? Okay, so what that means is I need to solve for y or x? X. So I'm solving for x when y is what number? 45. When y is 45, I need to solve for x. That'll tell me what the base of my rectangle is and what the base of my triangle is. Okay, and I need that number. The other thing I need is obviously the height of my triangle and the height of my rectangle. That value there is something Google Sheets spits out, and it should help you to get those two things. Okay, that's pretty much laying it all out for you. I've almost done the analysis for you at this point. Okay, so you guys have to get her done from here. I can't tell you very much more. Okay. All right, so that's going to get you, whoop. All right, so that'll get you that whole chart filled in, okay? And I do want to see your work for question number 3. All right, so show me your calculations, okay, for this. If you want to just do them by hand, that's fine, but then take a picture of your work and stick it in the lab report as a picture. Okay, one way or another, I need to see your work, and it all needs to be in that file. Okay, so you can either type it out or you can write it out, take a picture, and insert the picture. All right, then we got our conclusion. So restate your hypothesis. Were you able to calculate the acceleration in the way you had predicted in the hypothesis? If so, okay, then you can accept it. If not, then you have to reject it. Notice there's no sources of error on this lab. Why not? We didn't do it. Okay, I mean, we could guess at what the sources of error were, but you should never guess in science, right? So there's no sources of error on this one. You don't have to come up with any sources of error and ways to fix them because we didn't actually conduct the experiment. All right, any other questions on what you're doing there today? Yes, insert all 5 graphs. Okay, so the way you do that, just same as before, right? Just click on the top, copy them over, paste them in. Okay. All right, if there's questions as you go along, let me know, and I'll try and give you a hand with them. Realistically, guys, you should be able to get pretty far along in this today and not have too much homework. Right, and I put the due date on there. I think I made it next Friday, the 18th. Okay, so make sure it's done for then.